So one pretty standard application of exponential and logarithmic functions is Newton's law of cooling, which basically explains that the way an object cools to the surrounding temperature is governed by an exponential function. So we are given this equation here, which tells us the temperature of a cup of coffee, lowercase t, minutes after it's poured. Capital T is the actual temperature. Okay. So the first thing they're asking is, what is the temperature when the coffee is first poured, right? And what we're really asking here is, what's the temperature at T equals 0? And so to solve this problem, I'm simply going to plug in a 0 for T, which of course makes easy math. I get T equals 70 plus 100 E, and then when I multiply negative 0.0446 by 0, and I get 0. So that's just e to the 0, which is 1. So this is just 70 plus 100, which is 170 degrees. So the original temperature is 170 degrees. That's not a great degree sign, but hopefully you'll get the picture. Now for letter B, they're asking a slightly more complicated question. They want to know how long it's going to take before we can drink the coffee. And in their estimation, 120 degrees is drinkable. Okay, so we're going to put 120 where the capital T is, and then solve for the lowercase t. And this is an exponential function, and to solve exponential functions, we use logarithms. Excuse me. So we're going to do a little algebra here first. I'm going to subtract 70 from both sides. And I think you'll agree I get a 50 there. And then I'm going to divide by 100. I can't write as fast as I can talk apparently tonight. And when you divide by 100, you run out of room on your screen. So we'll continue this on the next slide, continue this on the next slide. But what you're going to see is I'll have 1/2 over here. Right? This reduces to 1/2, and these guys cancel. And then I'll be able to use logarithms to solve this. So we simplify 50 over 100, we cancel the hundreds, and we end up with 1/2 equals e to the negative 0.0446 t. The way you solve these types of problems is you take the natural log of both sides. So I'm going to take the natural log of 1/2 and the natural log of e to the negative 0.0446 t. You don't really need to worry now about the value of log of 1/2. You can type it in your calculator if you want. What I am going to do is just rewrite it in a little simpler form. Since 1/2 is 2 to the negative 1, this is really just negative log 2. And over here, since the log function and the e are inverses, they sort of cancel each other out, and we're left with negative 0.0446 t. That canceling out, you're not really allowed to do that. I probably should erase that. That's the practical thing that happens. But really what they are is inverse functions. They undo each other. So maybe I shouldn't officially cross those out. I should just say that when you take the natural log of e to the negative 0.0446 t, you get negative 0.0446 t. Okay, so now I'm going to get my calculator out. I'm going to divide by negative 0.0446, negative 0.0446, and the calculation comes out to t equals 15.54 minutes, give or take. I am going to clarify what happened right here, though, on the next slide, just so that you understand why I end up with the natural log and the e, quote-unquote, canceling. So let's just take a look at this expression. And what's really happened is an application of the laws of exponents, so laws of logarithms. Remember that natural logs, or any logarithms, allow us to turn powers into products. And the way that happens is that this exponent basically pops out here. So even though I didn't write that on the last screen, what really happened is I bring the 0.0446t out in front of the natural log, and I'm just left with that base, which was e. And we've learned earlier that the natural log of e just turns into a 1. So this is just 1 times negative 0.0446. And so that's what I mean when I say, oops, that's supposed to be a 6. That's what I mean when I say the natural log and the e cancel out. They really don't cancel out. We follow the laws of logarithms, and we end up with a natural log of e, which turns into a 1. And what we're left with is just the exponent, which is this guy. And that's how I was able to use that trick to help us solve the last problem. Hopefully I didn't confuse you too much. Keep the questions coming and have a good one.